lab in Tulsa, Oklahoma again, here for another experiment that you guys are going to be able to do at home, the parent or caregiver. Our experiment this time is going to deal with states of matter and chemistry. We're going to be making oobleck. If you'd like to make along with me, let's get our ingredients together. The first thing you're going to need is a big container to do your experiment in. The next thing you're going to want is some water. You're also going to need some pure starch. I'm going to be using cornstarch, but you can substitute for potato starch, tapioca starch, arrowroot powder. Any pure starch will work for this. However, you might have slightly different ratios. That's okay. You're also going to need some type of measuring device. You could even just use a regular old cup. Make sure you get a small cup if you do use this regular cup. A big cup's going to make it a little bit harder to play with the ratios. You'll also need a stirrer, a spatula, a spoon. You can even get a chopstick, whatever you guys like. This part is optional, but if you guys want to make it a little bit more fun and colorful, you guys could get some liquid watercolors, some tempera paint, some food dye, whatever you got to make our oobleck all kinds of crazy colors. And to keep this for later, you need a disposable tub that has a good seal, airtight, so you can play with your oobleck later. So while you guys are gathering your supplies, let's talk a little bit about states of matter. Now, there are three basic states of matter whenever we're talking about science. The first one is solid. So you can see right here, I've got some ice. Now my ice is a solid. If I take it out and I set it on the table, my ice stays in the shape of an ice cube. It doesn't change shape until it starts to warm up and melt and change state. My ice will melt into liquid water. Now, water is a fluid, and that means it's going to take the shape of whatever container it's in. Right now, it's in the shape of this container, kind of a cone shape. But if I pour it into this container, it's changed shape. It's now the shape of this container. If I was to pour it on the ground, it would take the shape of a puddle and fill the ground. So the difference between a solid and a liquid is that a solid has a set shape. It stays in one shape, whereas a liquid will take the shape of whatever container it's put in. Now, the last state requires a little bit of energy. So I've got my kettle right here. I've got some water in my kettle, and it's going to heat up the water, adding energy to it. Now, what's happening as I'm heating it up is all these little molecules of water are getting more and more energy. Imagine these balls are just little molecules of H2O. Whenever they were a solid, like ice, they were stuck together really, really tightly and couldn't move. As I added a little bit of energy, they're able to move and slide around each other as a liquid. Now, as I add even more energy, they start flying all over the place, bouncing around. This is going to cause my water to turn into a vapor or a gas. That's our third state of matter. Now, if you guys have ever had hot cocoa, hot tea, or if you've ever seen like soup bubbling, you've seen steam rising. That is an example of the water molecules getting enough energy that they can convert into steam and rise up. Similar to fluids, gases want to fill the container they're in, but they don't have as much pull of gravity pulling down into the container, so they'll expand and fill the entire room. They have enough energy they can bounce all around. For instance, this room is full of oxygen, a gas. The oxygen fills the room in every single corner. So now we can see that my water has started to boil. I'm going to go ahead and I'm going to pull it out so you guys can see. If I pour it into this one right here, you guys will see all that steam coming out of it. That steam coming out, that's all the water that's being converted to a vapor or a gas. So to reiterate, our three states of matter are solid, like ice, where the particles are really mashed together tightly, liquid, like water, where they've got a little bit of room to move around, and gas or vapor, where they have so much energy they can bounce all over the place. All right, hopefully you guys have grabbed your supplies and you're ready to get started. Now, the fun thing about making our oobleck is that it's a ratio. What we mean by a ratio is that we don't have to have a specific measurement as long as they're relatively the same measurement. We're going to do what's called a 2-to-1 ratio. That means I'm going to put twice as much cornstarch as I am going to put liquid in. So if I'm using a 1/4 cup, I would put 2 scoops of cornstarch and 1 scoopful of water in it. If I'm using just a regular old cup without any measuring markings, same thing. I'm going to put 2 cupfuls to 1. So that way the ratio stays the same. This way you can mix a very small amount or a huge amount, as long as you keep your ratios the same. So let's get started. We're going to take our cornstarch, and I'm going to measure up 1 cupful to start off with. Now, like I said, if you guys have got arrowroot, potato starch, any pure starch, this will work. However, be aware that yours might be slightly different than mine. That's okay. Because at the end, I'm going to do a little fine tuning with mine. So, I've got my cup measure. I'm going to pour cornstarch in there, pouring it over the bowl, so I try and get as little mess as possible. Let's see, is that even? It's a little bit over a cup, but that's okay. I'll just have to play with it at the end. Now, if I was going to stop right there, I would put half as much water in there. So I put in 1 cup of cornstarch, so I put in half a cup of water. But I want more oobleck, so I'm going to go ahead and I'm going to do 2 cups of cornstarch. This one I'm not going to fill it quite as much because that first one was really, really heavy, had a lot of extra. So I definitely want to try and keep as close to that 2-to-1 ratio as I can. All right, scrape off some of that extra. And so now I've got 2 cups of cornstarch. Now I'm going to put half as much water in there. So since I put 2 cups in here, I'm only going to put 1 cup of water. So I'm going to measure out my water. And if you guys are using any other cup, that's fine, just as long as you keep those ratios. And all I'm going to do is I'm going to stir as I pour. So I'm going to just, as I sprinkle this water in, mix it in, mix it in. You want to keep it moving because this stuff can sometimes clump up if you let it sit too long. You definitely want to keep it always adding and moving. All right, so now I'm getting a pretty good mix right here. Oof, I'm messy. How many of you guys are messy? The good news is I get to clean all this up later. All right, so we can see that my water and my cornstarch are starting to combine. Now, if you remember, my cornstarch was a solid. I could pour cornstarch out and it would stay the shape of a big pile of cornstarch. My water was a liquid because it takes whatever shape of the vessel that it's in. Whenever I poured it into this cup, it was shaped like this cup. When it's in here, it's shaped like this vessel. Oh, yeah, that's pretty close right there. However, I do notice I have a few small dry chunks that haven't quite mixed in. So this is where I'm going to have to fine tune it a little bit. Because I added a little bit over a cup with that first one, my ratio is slightly off. So I'm going to add a spoonful at a time. Do it just a little bit at a time because it's always easier to add a little bit more than it is to take away. So just a splash until you get that right consistency. And let's see now. So what do you guys think? What are we making here? Let's investigate it. Now, whenever we're investigating things with science, we want to use our senses. So one of our senses that we rely on a lot is our sense of sight. So I'm looking and I'm saying, this looks pretty gooey, it looks pretty liquidy, and I can see that it's all combined right here. Turning out pretty neat. Now, mine is looking pretty all right. So I'm going to use some more senses. I'm going to smell it. Does yours have kind of a funky smell? Not that I don't want to smell a lot of, but not bad. The next thing I want to do is I want to kind of listen, see if I hear anything. Is there any bubbling or fizzing? Is there some type of reaction going on? I don't really hear anything happening, so that just tells me that there probably isn't any type of reaction, bubbling, fizzing going on. Now, one sense we really never want to do unless we have really, really strict safety guidelines is our sense of taste. I don't just want to put things in my mouth because they might not be the best for me. So never put things in your mouth whenever you're using your senses to observe things unless it's under very strict circumstances. For instance, if you're experimenting with making bread or pasta or I don't know, some other things in the kitchen that are meant to be eaten. This one right here, I'm not going to eat. Even though it's technically food items, it's not really anything I want to put in my mouth. So now it's time for the fun one, the sense of touch. So I'm going to pull this guy out right here. I'm going to touch it. Ooh, what does it feel like to you guys? Feels slippery, soft, slimy. Now, one of the things I notice about this, even though it looks kind of liquid, whenever I do a few things to it, it acts kind of like a solid. It wants to stay in big chunks. So I can see that if I hold it up like this, it drips and it goos all up and it looks like a big, long, gooey liquid. But if I grab it and I pinch it, it acts a lot more like a solid. It's not gooey or liquidy. It keeps its shape for a little bit until then it turns back into a liquid and it starts to drip down, down, down. Now, you guys may be wondering, why is it acting like this? Well, this is a really cool example of something called a non-Newtonian fluid. So what that means is it doesn't behave the way we think it normally would. You guys might have heard that name, Newton, before. Isaac Newton was a very famous scientist. He devised a lot of laws of motion. He's the guy you probably remember with the apple and gravity and everything. But he came up with a way of determining how things should flow or move. But there's a lot of things that don't actually go the way that he thought they should. So those are called non-Newtonian. So this is an example of a shear thickening fluid. So in other words, the harder I try and stir it, the harder it gets. If I just stir it slowly and gently, my spoon goes through it pretty easily. The slower you go, the more easily it goes through. But as soon as you start trying to go hard, oh, it wants to chunk up and it wants to turn almost like a rock and impossible to move through. So this exhibits qualities of both a liquid and a solid, depending upon how much stress or pressure we're adding to this. Now, this is pretty fun, but I think I want to make it even cooler. Let's get out some of our colors. So I'm going to pick one color, and I'm going to give a couple of drops. If you want to measure a teaspoon, you can. If you just want to measure out drops, you can as well. The amount you add is going to change your colors. It's your experiment. So I'm just going to give it a good squirt right there with my blue. Now I'm going to watch and see what happens when I added that. I'm getting all sorts of fun. Look at those blue strings dropping down right there. Oh, man. What does this remind you of? You guys ever seen anything look like this before? Ooh, that's really cool. I'm getting all these fun little kind of, almost looks tie-dyed. Let's see if I can pick that up. Oh, yeah. Look at that dripping down. That's fun right there, isn't it? Now, you may be wondering, why does it behave this way? We talked about the three states of matter, and this one looks like a liquid, so it should act like a liquid. But the reason is because it's actually a liquid that has a solid suspended in it. My cornstarch is still solid. My water is still liquid. What's happening is those little particles of cornstarch are kind of floating in the water, and they're able to kind of move around each other. They can kind of change shape whenever I'm gentle with them. But whenever they get a lot of pressure, they get squeezed down and they don't move very well. So whenever I push down really hard, that makes those little molecules, instead of having a little space, they squeeze down tight. And so that's what's happening, is they lock together whenever I try and push them together. So that's why it's acting that way. Ooh, what color did you guys do with yours? I don't know, this blue is pretty cool. I kind of want to mix it anymore. I love all the stripes and everything's happening. But I know as I mix it, it'll start to get together and I'll end up with this kind of fun light blue one. Let's get another big, oh, that's so fun. How it strings out like that. So how many things have you guys seen in your house that behave like this? Believe it or not, there's actually a lot of things that are considered non-Newtonian fluids. And I'll bet you use a couple of them on a daily basis. How many of you guys have ever had syrup or honey? Yeah, whenever you guys try and get it out, it feels really thick and really hard to get out. But if you give it a good squeeze, it comes right out. If you just hold it upside down, it really wants to stick in the bottom. Kind of like ketchup or shampoo. Whenever you squeeze it out, it looks like a liquid, but then it holds its shape like a solid. Lotion's another good example of that too. It has properties of both a solid and a liquid, depending upon how much pressure or stress it's under. I'm going to go ahead and I'm going to add another color so we can see how it kind of mixes together. What do you guys think? Should we do green yellow, or red? I think we're going to do red because I think that's going to have a really cool extra little bit right here. So what do you think is going to happen whenever I mix together my red and my blue? Am I going to get cool red, white, and blue stripes? Or am I going to get like green? Or am I going to get yellow? Or am I going to get purple? What do you guys think? Well, that's the fun thing about science. Whenever we have an idea, a guess or a hypothesis would be the science term for a really good guess. We get to test it. That's what experiments are. They're testing our best guesses. What are some guesses or ideas you guys have about this experiment? Could you do that at home, you think? I bet you could. So if you guys have any ideas or thoughts about ways you could experiment with this, that's awesome. Oh, there was a big chunk right there. So if I get this big chunk right here, you guys can see that if I kind of wad him up and I roll him, I'll roll into a big ball. It'll stay the shape of a ball as long as I keep moving and rolling it. It actually starts to crumble apart. And then as soon as I stop rolling it, it goes right back to a liquid. Now it's turned purple. So I was telling you guys about a few other things you have in your house that are non-Newtonian substances. Now, our word for how things kind of ooze or flow or move is called viscosity. If something's very thick, very viscous, it doesn't want to go out very easily. If you've ever tried to pour out like molasses or syrup, you know it's very thick and gooey. It doesn't really want to come out very easily. But something like milk or orange juice comes right out real easily. So I have a really fun way to show that to you. I've got these tubes right here, and they've got balls inside of them. Now, I'm going to flip them over, and we're going to see which one the ball goes down the fastest. Which one do you think? So let's see. Which one do you think the ball's going down the fastest? I've got red, green, gray, blue, and black tops. You can see they're all pretty close to the same color. This one's a little bit more yellow, but the rest of them are pretty clear. All right, you ready? 3, 2, 1. So I flip them over, you guys can see those balls start sliding down, and this one's already at the bottom. This one just got to the bottom. This one got to the bottom. This one's almost at the bottom. You can see this middle one, this gray one, is taking forever. This is a very thick or a very viscous liquid. It takes a lot of pressure to move it out of the way. This one was very thin. It was not very viscous at all. So the viscosity or the thickness of things can change depending upon the pressures we put it on. How many of you guys have ever tried to get toothpaste out? Sometimes it takes a lot of pressure to squeeze it out, and it comes out looking a lot like liquid. But when it sits on your toothbrush, it stays the same shape. Ketchup's a pretty fun example. If you guys have ever had to try and get ketchup out of a bottle, you know sometimes it gets really, really stuck in there like it's solid. But if you give it a couple of good whacks or a good shake, it comes out a lot more easily. Ketchup is the opposite of my oobleck. Ketchup actually gets thinner the more pressure or stress I put it under, instead of getting thicker. So to show you, I'm going to take this guy right here, and I'm going to squeeze out some ketchup in here. So you guys can see my ketchup stays in there really solid. It doesn't want to move around. It doesn't behave like a liquid. But whenever I open this up and squeeze it with the pressure, you can see it drops out like a liquid. So as I squeeze or add pressure to it, it turns more liquid. But as I stop adding pressure, it turns more solid. The opposite of this guy. And there's a little bit of that. So now you can see it's staying the same shape. It's kind of mounted up. It's not moving very much. But if I add some force or some pressure to it, some shear strength, you can see it behaves a lot more like a liquid. So as I'm spinning this guy around, it's acting like a liquid as soon as I stop. It'll go back to being a solid, all congealed there together. So this is another example of a non-Newtonian substance. What are some things that you guys can do at home to test to see if they're non-Newtonian substances? Remember, there's a lot of different ones. Some of them will change with temperature. Some of them will change with time. Some of them will change with force. They might get thicker, more viscous, or thinner, less viscous with time. So let's go back to my oobleck and take a look at this guy. So yeah, he's just nice and smooth as I draw my spoon through here, nice and slowly. Once I just kind of follow it, I try to poke it. I just try to gently put my spoon in, go to the bottom. But if I try and stab really hard, it's like a brick wall. Or if I get it to the bottom and I slowly pull it out, you can see it acts a lot more like a liquid. But what happens if I try to pull it out really, really fast? Oh, did you see that? It stuck so hard in my spoon, I actually lifted my bowl off the table because it was so solid and stuck on there. Oh, I should probably stop. That's glass, and I don't want to clean up a lot of glass. But this is so fun to play with because it's so simple to make. Now, if you like me, a little messy, you got to your hands. That's okay, because as it dries, it turns right back into cornstarch. All you really need to do is kind of dust your hands off or get a dry towel and just wipe them off. As you get more water on it, it's going to turn back into this oobleck. It's going to be sticky. It's a lot easier to wipe off when it's dry than whenever it's wet. So that's my tip for you guys. Try and get it cleaned up when it's dry, not wet. Also, if you got it in your clothes and anywhere else, you can just take a butter knife, scrape it off, vacuum up the dust. So it's really easy to clean up. Now, I talked about keeping this for later, and that's okay if you guys want to put it for later, have it out. But whenever you're disposing of it, never put it down the sink. You see how hard this is? If you put this down your sink, it would plug it up really badly. Always dispose of this in the trash can. You need to throw it away in the garbage. Or you could put it into a compost bin if you'd like, but never the sink. Because, like I said, you don't want that stuck in your pipe. Mom and Dad would not be happy with you. Plumber wouldn't be happy with you. I don't think you'd be happy with you if you close out a lot of stuff. All right, now you can see I've got this beautiful curve. Now I'm going to do something. I'm just going to roll it around. You guys can see it flows so much like water. It just wants to kind of curl around it. But I try to shake it upside down. It doesn't come out. That's because I'm still adding force to it. Whenever I shake it, I'm still adding that force to it. So no matter how you add that force, stirring, picking it up, dropping it, whatever, it's going to behave differently. Scrape this down so you can see it again. Something else that's fun is this guy has different densities. What that means is that it's got different weights. So if I add a little bit more water, what would happen is this guy would get even thinner and be less dense. How many of you guys have ever been swimming and you're able to float really easily? Cool. That's because you were less dense or lighter than the water. So now if I take a wooden ball and a metal ball, which one do you think is more dense? The wooden ball or the metal ball? Well, the metal ball is more dense. It's heavier. The parts that make it up are crushed in it so tightly. So if I drop my wooden ball in here, it starts to sink down a little bit slowly. If I drop this guy here, oh, he gets with such force, and he sinks all the way to the bottom. He's so dense that he wants to roll all the way to the very bottom and get completely covered up. Try and pull him out. Oh, it's stuck in there really good. Now, what color did you guys turn? That sounds pretty cool. Well, let's go over the things that we talked about in our experiment today. So the first thing we talked about is we talked about states of matter. Remember, our three basic states of matter are solid, like ice or rock. Liquid would be something like milk or water. Gas would be things like oxygen or water vapor, air. As we get hotter, we tend to go from solid to liquid to gas, just like how my ice cubes melted as they got hotter and hotter and hotter. They turned from solid to liquid, and I heated them up all the way. They turned to gas. Whenever we combine our water and our cornstarch, we use a ratio. That means that it's relative to the other. It's a 2 to 1. As long as you use twice as much cornstarch as you do water, it'll be good. Or putting it inversely, use half as much water as you do cornstarch. It's still the same ratio. Whenever these are combined, they create fluid, which is a non-Newtonian substance. That means it doesn't behave the way that I just never thought it would. an example of a shear thickening substance. That means that as I move it more, it gets harder and thicker. But as I kind of let it sit for a while and I don't add any energy to it, it gets thinner and less viscous. It wants to just kind of flow out like a liquid. Remember our word viscous. Viscous means thick and resistant or hard to flow. What thing in your house do you think is the most viscous or the hardest to pour out? I wonder if you could do a test to find out what things are the thickest or the most viscous. Last but not least, we discussed density. Whenever things are packed together tightly, they're very dense and heavy. Why do they have space in between them? They're very light. Well, I hope you guys had a lot of fun playing with me and making some bootlegs. Remember to clean up your mess, and if you're getting rid of it, throw it in the garbage, not the sink. This will keep for a while in a airproof bag, so you can keep it and play with it more. Just make certain that you try and keep the messes to a minimum. All right, well, I think that's going to do it for us here at Discovery Lab. I've been Mr. Dusty, and thanks so much for hanging out with us, guys.